This video is more of a show and tell on 3D. Maybe you're interested in it, you'd like to know what it could do for you, but you don't really want a bunch of technical babble. And that's what we're going to do today. We're just going to go through and see how simple it is. There are 3 phases to making an object. So there's the design phase, which a lot of people really enjoy. It's a lot of fun. I'm going to use something called Tinkercad. It was originally designed for children. It's very simple to use. It just combines basic geometric shapes to form the things you want. You can see some of my past projects. Here's a crank I've already done, some basic blocks that I'm using for a radio. Down here is a knob. It's a replacement knob for an antique radio, and some other basic shapes of things that I needed. Here's a base for a crystal radio and so on. So these are all just simple geometric shapes that have been combined to produce what we want. Okay, so let's jump into it. Here's the create. So in this first phase, we are going to get a blank build place, they call it. Some people call it a build plane, whatever. And this is basically the board of the 3D printer. I mean, this is what it's going to look like when you start printing. So they give you the actual board that you're going to be looking at. And to create a crank, I just grab a box, and you say it doesn't look like a crank, but okay. So let's say we want it to be roughly 3 inches long. I'll call it 80 millimeters. Yeah, it's all in metric. And so that is roughly, it's a little bit over 3 inches. And now you can rotate it around. I'm pushing the right mouse button and just moving the mouse, and it can rotate it around like this. So I can see all the different angles, which is very cool. Now I can go like this, and here is the center of the object, and I want to put it right here. Do I have to put it right there? No, but it makes putting other objects on there and lining them up so much easier. Okay, so now I've got it lined up on those crosshairs, and yeah, you say that doesn't look much like the arm of a crank, and you're right, it's kind of too thick. So how thick would we want it? Maybe, I don't know, say 12 millimeters? Maybe it looks a little bit too thick. Maybe we'll call it 10. Now, if you don't like moving things up and down, my hands aren't steady, so you can just go over there, highlight that, and type in the number you want. And now I've got a 10 millimeter bar, and the 10 millimeter bar is 80 by 20 by 10. Okay, so that's starting to look a little bit better. Now we want, it's kind of ugly to have square ends on it, so let's put some round ends on it. So I will go over here and grab a cylinder and drag it over here. Now, you can see that this cylinder is gray, and that's because it's marked as a hole. If you look up here on the right, you can either have, an object can either be a hole or a solid, and we want it to be a solid, obviously. The whole thing will come later. So all we do is we put it over where we want it, slide it into position, and we're basically melting these 2 pieces together. Like that. We can flip it over, make sure it's still aligned. It is. And okay, it looks good, except for, oh, it's too tall. So we can fix the tallness. We know how to do that. Just click on here. What did we say? The other one is 10? Yes. So now we have a nice rounded end. It's still got square corners, so I overmoved it. So we'll move it back up here like that. Okay, so now we have nice rounded ends, and we can view it. Yeah, so that'll be more beautiful. Now, do we have to repeat all that? Not really. I can click on here. I can do a Control C, which means copy, and then a Control V, which will paste it, and I can line it up, and then I can just take my time. I'm using the down arrow on my keyboard and putting it in place. So that's starting to look like a crank arm, huh? Okay, so now we need a knob to grab, and we're going to go back over here and get our cylinder, make sure it's a solid. And it's not, it's a hole, so we will make it a solid. And how big should we make it? 10 by 10, that seems kind of small. 10 is about a half an inch. So I'm kind of looking at my fingers saying, how big around do I want something if I'm going to grab hold of it? And if we compare it to that, it's maybe a bit small, but we can change it. That's the nice thing, is we're not fixed. We can grab the object and change the size of it later if we wish, but that's not too bad. Okay, now one thing we haven't done is, you see this object is sitting, it's actually buried down inside here, and we can just grab this little pyramid and we can lift it up. In fact, I can lift it right on out of there, but what I want to do is I want to join it. I just want to have the two merge, and then they are basically welded together. We're just melting all these parts together. And a little taller maybe? A little taller, maybe 25 millimeters would be an inch. Okay. Could I grab onto a handle that's an inch? Maybe a little longer. We'll go full. Let's go 30. Okay, 30 is good. Yeah, so you could grab onto that. Let's make it a little fancier. I'm going to go over here. I'm going to grab this ball from the right side. I'm going to put it there, and then I'm going to reduce it. I'm going to squash it down so it's no longer a ball. It's an ovoid or whatever you call it. Oops. Let's see. I need to lift it up, and I did the wrong thing. Okay, here we go. Grab the little red pyramid, lift it up. Now I need to move it over into place. Grab it. Move it over. Am I lined up? Almost. Now we can look around. Well, I could do that, but I don't think so. Okay, centered, centered. And it looks like, yeah, it looks like that's all ready to go. So, yeah, that's pretty much a knob, huh? Now, it'd be really wonderful if I didn't have to drill a hole through here, because 3D printing, the material's not solid unless you tell it to make it solid. And you don't usually want to do that because it takes forever to print, uses a lot of plastic, and it's totally unnecessary. These things are fantastically strong as it is. So what I did is I went over here and I grabbed our cylinder again, and I left it as a hole. And we're just going to make a hole right here. We're going to click this. I happen to know I need an 8 millimeter hole for the shaft I am working with. And I will line it up, and then I will scoot it right over the top of here. Let's see if I got it centered. Now, by pushing the shift key and the right arrow, I can actually lift the whole build plane, so I can put it right in front of my eye. I can flip it over. I would say I'm a little bit off. A little bit off. So you can either do this exactly, or you can do it by eye. There we go. So you say, oh, the hole's too tall. Well, that won't make a difference. In fact, I oftentimes will make the hole go all the way through the work plane, just to make it clear to the 3D printer that that's what I want. I want a hole through there. Now, as you can see, we have a crank. It has a hole in it. It's ready to push on the shaft. And all we need to do is the next step. Now, it would be wonderful if the 3D printer could look at this picture and just print it, but it cannot. So fortunately, there's another program that's absolutely free, and it will take this and it will convert it into commands that the 3D printer can understand, and you don't need to know any of that. All you need to be able to do is push one button, and it will do the conversion for you. Okay, so from here, I need to move that file over to the other program. I say export. I say everything in design, which is right here. I prefer the STL, so I'm going to push that button, and up here it will pop up as, oh, that's a terrible name for it. I'm going to change the name while we're here. hand crank 05A. There, much better. Now I'm going to say export, everything in design, STL, and now I have a beautiful name. I can show in folder. I can grab this and cut. I can take it to where it needs to be over here, paste it, and now we begin phase 2. So in phase 2, I'm going to use a program called Cura. You just download it off the internet. It's free. I'm going to click on this, and it's going to open it up, and there's our crank right there. There are a lot of technical things you can do at this point, but again, I promised you this is a show and tell, and it's not going to be high tech. So in order to create the file that the printer can read, I just go down here where it says slice, and I push that button. And that's it, it's done. It tells me it's going to take 1 hour and 40 minutes for the printer to print. It's going to take 11 grams of filament. Preview. I can actually go down through here. I can grab this knob over here and I can go slice by slice. That's why they call it slicing. I can go layer by layer all the way through here, and this is what the inside of this thing is going to look like. You can see that it's not solid. It's full of this, of a crosshatch shape, which makes it remarkably strong. And then it'll put a solid face on it, and then it'll print this right here. It'll go up, it'll print the end of our knob, and that's it. So that's what it's going to look like on top of the 3D printer. I need to save this to disk, and yes, right there, it's called G-code. I'm going to save it. Now, just in case you're curious, what is the printer doing with this stuff? It's actually converted it from just this photograph, or this 3D model, I should call it more properly. This 3D model, it has converted it into a bunch of X and Y coordinates, just like you learned in grade school. So if we open up this file, now it's full of a lot of junk, but it's just instructions to the printer. And you can see most of it, it just says X and Y, X and Y, X and Y, and the E is the extruder, how much plastic to put out. So it's got command. It says move the nozzle to the X coordinate here, the Y coordinate here, and then extrude a certain amount of plastic. And it just does that. And I mean, these files are really long. I mean, it's every dot of plastic in the crank has to be specified. So fortunately, we don't have to do this by hand. Fortunately, we don't have to do anything with this file. This is what the 3D printer is going to be reading and converting into our crank. So now what I'm going to do is I'm going to save this to an SD card, and then I'm going to walk that down to the printer, and I'm going to start the printer up, and it's going to create the crank that we just built real time. This is a 3D printer, and up here is the plastic filament. It goes down here, and it literally squirts out here onto the bed in the pattern that we have defined. So what I've done is I've got our SD card, and it goes right in that slot. It's got our program in it, and probably shouldn't call it a program, I should call it our design. And I go up here and I look for attach card, fine, print from card, and there is our file, and we push this and say print. And it's going to start going. I'm going to change perspective here. Here's our finished print. You say, what's this stuff out here? This is called stringing. It just comes off. You can just rub it away. But yeah, I mean, a little bit of fingernail there. Get my hands out of the way. And you can see that there should be a satisfying little pop that comes off of there. You can see that it is, minus these things, it is pretty much what we executed upstairs. So yeah, that's it for 3D printing. I mean, as you can see, it's a lot simpler than you might think. Just the 3 phases. You go through your design, your slicing, and then the actual printing, and you end up with your final result. Of course, you can always tinker with it and make things thicker, shorter, stronger, more plastic, less plastic, and all that good stuff. Okay, well, I hope you found that interesting and satisfying your curiosity about 3D printing.